We have started recording. All right, let's do this. First off, I apologize if I sound tired. It's because I am tired, but I'll do my best to get through this workshop. I will be transparent. It's going to be a little bit of a longer one, and you're also going to notice that none of these slides are, I'm going to stop my recording again. I can't make that mistake. There you go. All of these slides, they're not with our normal NightHacks template. I've actually ran this workshop, I think, 3 or 4 times now personally before I decided to bring it to the rest of the club, because I feel like it's a little different in the normal workshop style that we normally do. But I think it's gone well, so I'm excited to bring this one to you guys. With that being said, the last few times I've ran it, it's gone to about 2 hours. So if y'all need to leave early, that's fine. I won't be offended, but hopefully I can get you guys good information that kind of makes you want to stay. I think it's a really, really good workshop. I'm giving it to my mentees, my friends, people I'm working on projects with. And so, yeah, another question before we get started. I kind of just want to gauge where everyone's at. Who is taking processes of object-oriented software development? Poost, you got 2, okay, in class. I know you're in my class, or saw you up front. So everyone else, I would presume, is before that. Good. So that's the target audience. For those of you in Poost, I think I can still offer something of value, but this is Hello World Workshop. It's mainly tailored towards genuinely no idea what HTML even is. We're going bare bones here, and if you don't know what that is, that's perfectly fine as well. We're going to dive very, very deep into the core fundamentals of what makes a website, right? Another thing you're going to notice is there's going to be a pattern that I'm going to follow at the beginning of the workshop, because through my personal experience with web development, I made the mistake of jumping right in. And by that I mean I picked up a framework right away before even learning JavaScript. I did all of these really, really modern, complex tools without first learning the basics. So that's what today's going to be. Not only are we going to talk about what those fundamentals are, what those basics are, we're then going to talk about modern tools and why they were built and how the not so desirable things of fundamentals sort of inspired all of those technologies. So I think it's going to be really insightful, so that if you ever have a problem in terms of web development, you know where to reach, you know what to look for, and you kind of have an idea of what to look up, right? Because it's always hard when you have a question, but you don't even know what the question is, right? You're just at a point where you're like, what the hell's going on? I have no idea where to even start. And so hopefully this workshop helps answer some of those questions. Another thing that's different is this is actually gonna be no code. So I see lots of laptops open. Don't expect a VS Code terminal open this workshop. Instead, maybe take some notes. That's more of the approach that we're going for here. It wouldn't be a NightHacks workshop without code at all. I'm going to be showing code snippets to demonstrate some of the paradigms I talk about, but we're not writing any code, right? This is purely going to be fundamentals, concepts, etc. And this workshop is actually part of a 2-workshop series that I, again, run for in private. And the second half is where I really dive into code, which I think I already have it scheduled down on our calendar for, 1 second, let me check. I believe it's about a month from now. It should be Intro to Full Stack on our Discord calendar. That should be April 15th. So that one's a lot more high complexity. One more disclaimer. I feel like I'm doing this a lot, but I just really want to set the expectations. This will purely be going over websites, not web apps. What's the difference? Primarily, I'm not going to be talking about APIs or databases at all, right? I will be talking about them conceptually, but I'm not going to go over an API framework or a database framework. We fully need to understand what a website is before we start figuring out all this stuff in the back end and adding on to that, right? So that's all my disclaimers out of the way. Awesome. So the 3 objectives that I kind of put on this workshop is you all will leave with an understanding of the purpose of modern web tools by comparing to non-modern counterparts. And again, this is to give you an idea of what tools to reach for when you encounter a problem. Attendees will understand the difference between client and server. This is a paradigm that I'm going to be talking about a lot that's going to help you set that fundamental understanding for when you do start adding APIs and databases. And then attendees will get exposed to modern web technologies to reach them during personal projects. Kind of the same thing as the first bullet point, but I thought it looked awkward with 2, so I added a 3rd one. So, quick table of contents. Keep in mind that the way I built this, the final goal of this workshop is for you to be able to have a fundamental understanding to actually build a portfolio. And I'll spoil that at the end, because my groups, when I ran this, weren't very happy that I assigned them homework. I genuinely told them, go back, make your portfolio, and until you do, I'm not running the next workshop. And so they all have portfolios now, which is really cool. And I'm not going to do that for this group because it's NightHacks and I can't really fact check everyone's portfolios, but that is the goal in mind. So the first things first, talking about building a website, talking about the concepts we need to know, talking a bit about servers, and then lastly, I just have a little mention on deployment, very, very small section. 1 and 2 are going to be the big beef of this workshop. So we're going to get through 1 in like an hour, and you'll be like, man, there's no way we're going to be here for the other 3. They're quick. So yeah, first things first, I guess we can jump right in. Let me take a quick drink. So I'm going to be talking about actually building a website. And so there are kind of different components of a website. I'm personally going to be lecturing on the stack that I prefer, because why would I try to sell you something I don't use myself? I don't know anything about it, and nor would I be good at explaining it to you. So again, not saying that these tools are the best. These are just the tools that I use and that I wish to expose you all to. If you want to explore more on your own, absolutely go ahead. That's great. But the main tools that I want to talk about from the modern perspective is going to be JSX, Tailwind, and React. These are the 3 sort of tools that you're really going to be reaching for a lot when you're working on any sort of front-end site. Keep in mind that JSX, I think I talk about it on the next slide. JSX is basically an extension on top of HTML. If you don't know what that is, don't worry, I go over it. Same thing with Tailwind. Tailwind is how you style your websites, how you make everything colored, how you change all of the text, the fonts, the spacing, etc. And then React is an interesting one. It's called a framework, a JavaScript framework, state management system, state framework. There's a bunch of different ways to describe them. But React is sort of kind of like a tool that is lets you use JavaScript in a more effective way. And again, I'm going to go into that soon. So first section is the bones of a website. So how is a website structured? And by this, I mean like genuinely just the content that's on there. Nothing about how it looks or the styling or anything like that. And that brings us to HTML. So talking about HTML, by show of hands, who's heard of HTML? Cool. All right. Keep your hand up if you've opened up Inspect Element. Congratulations, you guys are like experts now, right? If you've opened up Inspect Element in your browser before and like fucked around and like changed text, okay, you've edited HTML. It's not super duper complex. And if you want to look at how a website's built, go find one that you like, other than my UCF. Go find one that you like, right click, Inspect Element. You can look through all the HTML and you can try to get an idea of how the website's structured, right? But essentially what HTML is it is a series of nested elements that represent a website, right? And the biggest thing that you need to keep in your mind for the next 30 minutes until I get to the part where it matters, can be represented as a tree of parents and children in something kind of like a graph. Who's taken CS1 or CS2? Okay, cool. So we have a general understanding of what like graphs are, like linked list trees, all that type of stuff. So that comes in handy later on when we talk about React. The other thing about HTML is that it's redundant and static, no way of serving data or state. And by that, I mean HTML never changes, right, on its own. So all of the interactions that you do on a website, imagine hovering, or I guess it's a bad example, clicking something and something appearing, that's the HTML being modified or styles being modified. HTML has no concern with that. HTML is purely the structure and the content of the website, right? And so of course, I mean you can, but writing a website in just HTML is going to look like one of Dr. Guha's pages. Has anyone seen his CS document thing? Yeah, there's like no styles on that. Like that's just pure HTML. I don't know the stance he was taking there, but I kind of like resonate with it. It's cool, right? So remember when I talked about graphs? This looks scary, right? But all this is saying is, again, this is the parent-child relationship of HTML that I like to talk about. As you can kind of see here, if you kind of trace everything, the HTML element is kind of like the great-great-great-great-great-grandparent. It's like the parent of all parents, right? And from there, you kind of branch downwards. And so this looks a little confusing to understand, but I think I could give it an example of something better. So I'll go ahead and go to my own portfolio, just because I know how to navigate it, right? If you open up the HTML right here, and so as you can see, the HTML component, all of this code inside of it, notice how it's indented. In HTML, to denote a child, it's indented and wrapped. So by that I mean all of this text here is indented one, and the HTML wraps it. It's above and below it, right? And so you can kind of see as we expand here the parent-children relationship here. So HTML is the parent to everything, whereas the head element is parent to everything inside of here. And so this is probably a nicer way to look at this, but fundamentally, keep in mind that they are the same thing, right? So this is how we can represent HTML. And all of these are really, really important for when we actually want to manipulate the website later on, right? Imagine that we want to, I don't know, make 10 buttons that all do the same thing. Instead of defining like each of those buttons, we could say maybe all buttons that are children of this div, right? This is a terrible example. I didn't come up with that ahead of time, but you can kind of see how it's important to have those relationships, because without them, you can't specifically pick something on the website to mess with, right? Oh, I already had an example here. Perfect. I should have the slides up ahead of me on the right. But yeah, this is an example of HTML, a much more simple example, because the HTML you saw on my screen on that website was actually like minified with all the classes, and it kind of looks like a mess. This was my first iteration of my portfolio. This was like raw HTML, CSS, JavaScript, right? I did this like 3 years ago. I was trying to do it in high school, and then like I basically just Googled everything and didn't really take time to learn it. So this is kind of like what it looked like. As you can see, it's a lot more simple here. There's like at most like 2 indents from header, right? But this is just generally speaking. So for example, all of these A tags are children of nav, right? A and nav are siblings within this div, right? Hopefully my mouse is evident. And then header kind of wraps the whole thing, so that's like the parent of everything, right? So again, parent children. Here's more code, but the biggest thing I want to point out here about HTML is, do you remember how I said it was redundant? This is going to be my example. This is my project section, right? On a portfolio, you want to have the ability to showcase your projects, and you want all of them to generally look the same. Consistency goes a long way, right? So like you all want the cards to be the same, and you want them to be spaced evenly, and you want them to kind of just have a general consistency to them. Well, you're going to be writing, if you notice here, the same HTML over and over and over again. And the more complex the card gets, the more indents we have, the more crazy effects that we do, you're going to be writing a lot more HTML than maybe even the text inside of it, right? So you're now at a point where you're writing more code than info, and that's just not, I mean, that's not how it's supposed to be, right? Your main focus should be getting information out, not really thinking about the code. And the more you can abstract it away to save yourself redundant work, it helps, right? So for example here, this is one of my old projects from a while ago. I have a section, an image, an H3, a P tag, an A tag, section closing. And I have this exact same thing here for my Discord bot project, right? And imagine if, for whatever reason, you don't decide to copy and paste and you decide to manually type it out again, getting a typo in one of those, right? Or what happens when, okay, all of these cards right here, what if I want to change all of their colors, right? Now it's doable with CSS stuff, but what happens if I want to change, I don't know, if I want to add work in progress to the right of all my work in progress projects? Then I have to go manually edit all of them, right? So that's the redundancy of HTML. It's static. Once you write it, it's done. That's what it is. And if you want to modify it, you have to modify it everywhere. And so that's one of the problems that HTML poses, right? And so that's where JSX comes in. I want you guys to keep in mind that JSX, it's like, actually, I'll say that later. I don't want to confuse anyone. I like to call it the prodigal love child of HTML and JS. Very professional definition, and it basically functions the same way as HTML does, but it allows for you to use JavaScript to generate the HTML. A little weird, right? But we can use JavaScript to write HTML in our syntax. And so an example of this, again, solving the same redundancy issue, is this. I wish I still had this portfolio hosted. One of the things I wanted to do is I had a bunch of cards that go over my skills, right? They were like a bunch of little logos on my portfolio, and when you hover them, I wanted it to display the text of like what it was, because like imagine a recruiter doesn't know what the Tailwind logo is. You hover over it, it says Tailwind CSS, and you're like, oh, okay, he knows whatever that is, right? Because who knows? And so again, if I were to do it in this approach, I would have to write all of that HTML for every single skill, and keep in mind, I wanted to show a lot of them, even though like I used some of these for like 2 weeks. I'm like, yeah, I'm skilled enough to put on my portfolio now, but still, right? So you want to have all of those. You would have to write all of that HTML, right? And again, some people like to have really cool animations on them. What happens if you want to change the animation? That's not something you could do with just CSS. You have to like go in there for some of the complex interactions. You have to change all of those. So what JSX allows you to do, and again, if you don't know JavaScript, that's perfectly okay. Just understanding it conceptually, that we can use some sort of code tool to generate our HTML. In JavaScript, there's something called the map operator, and it lets you do something to a bunch of things in a list or an array, right? So essentially what we can do is, I have my skills array right here, right? As you can see, all of them are of a similar shape. It's an object with a name parameter and an SVG parameter, right? And so now, since all of them have this same information, and I want them all to take the same shape, it's really tiny. But if you guys can see here, skills.map, it's then going into, so from this open bracket, or open parentheses, to this open parentheses down here, right? I am generating a piece of HTML for everything I map over, right? And so this concept is cool because all I need to do to add a new skill is write one of these, an extra line, right? Which compared to rewriting HTML, copying, pasting it over, and making sure everything's the same, this is definitely a lot nicer, right? The other thing is too, is that you can do a lot of really cool things in the sense of like, right here I have an animation of like when the mouse enters and when the mouse leaves, but essentially when you map, so skill is the actual individual object, and if you see here, I have the, let me see, so yeah, it says right here, skill.name, right? Don't worry about this god-awful mess, I'm gonna get there, right? But specifically the thing I'm talking about is skill.name. And right here, the text. So skill.name, and it's basically saying, hey, if the hovered skill is this current skill, we're gonna display the name, right? So this is a bunch of JavaScript React stuff that I'm gonna get into, but the whole point is you get the idea that by having this map operator and being able to write JavaScript in our HTML, we save us all of this, right? Another thing that's really, really powerful about JSX that makes things super, super cool is the idea of turn areas. Does anyone know what a turn area is? Okay, so it's not super duper complicated. Turn areas are supported in most programming languages. You could have even used them on your foundation exam in C. Essentially what a turn area is it's a if-else statement, but instead of being 4, 5, 6 lines, it is all in one line, right? So imagine, here. Imagine we're in a C program and we wanted to basically have a value. We wanted to return 1 if it's true, or 0, no, that's a bad example. We wanted to return 5 if a variable is true, or 2 if it's false, right? So what we could do is we could say variable. So basically saying if this evaluates to true, then this, else this. That's the syntax for a turn array. So the question mark is basically saying if, and this is saying else, right? It's not super duper complicated syntax, but you're allowed to use it in JavaScript. And the power of that is, this is a project I made where I had people, I had like a Stripe thing and I wanted people to subscribe, right? Because I'm greedy and I like money. So if they are subscribed, this is a Boolean value, true or false, then I want to give them the manage subscription button. Else, I want to give them, hey, give me money button, right? So if you look here, this HTML, just dynamically, using JavaScript in it, JSX, we are able to do this with just this, right? And that's super cool because normally what you would have to do is you would have to, do that in your HTML and then have to like define all of that behavior on the JavaScript. With JSX, you just put it in, we're chill, right? So that's super cool. Next up, how is a website styled? Because I don't know if we're all like big fans of the Guha site, so we want to make everything look good, right? And so that's where CSS comes into the picture. CSS stands for Cascading Style Sheets. You never need to remember that ever, but that's cool if you wanted to. The primary purpose is styling elements in HTML, and what styling consists of is not only how it looks, and by that I mean color, size, font, but also the positioning of things. The CSS defines maybe you want your buttons to be in a row instead of a column, because the default behavior in HTML is to just throw them all on the top left side of the screen, right? And so that's what CSS is, and that's what lets you make your website not look super duper old. And so remember how I mentioned Tailwind CSS? That is a superset of CSS, and I'm going to talk about just basic CSS for now. And in the same style, I'm going to point out some of its issues, and then we can start talking about modern tools and cool stuff like that. So this is how you would normally have to do CSS. You would have to have a separate CSS file, and you would need to link it somewhere. I don't have the code linking it here, but it's just like a tag at the very, very top. It's like link stylesheet.css, right? And what that does is it allows all of your styles here to then be used in your HTML. And so by that I mean, if you notice here, .education, the dot syntax is saying you can give something this class and it will apply these styles. So if you look up here in this section, I have class education, right? Item details, main section. Again, I didn't have so much room on the screen. The only thing you can see here is the education. But the other thing is you can remember the parent-children relationship. So what this is saying is that of all elements that have the education class, target any children paragraphs. So all of these P tags here, here, all of these, they have with 60% because they are children of an education class and are of type paragraph, right? Pretty straightforward. But there's a lot of problems with this, in my personal opinion. Let me see if I have more examples. Yeah, and then this is what it looks like, this mess right here, to make things responsive. So you could imagine you don't want your website to look the exact same on a phone as you do a desktop. Because if you do, it's gonna run off the side of the phone and you're gonna have to scroll to the right and like, sometimes I'll be like ordering food on Google Maps and if their site side scrolls me, I don't eat there. It's ridiculous, right? Because like, why are we doing this in Big 25? And so this is how you do that with vanilla CSS. You would have to define, basically you'd overwrite all of the classes, the normal ones, just wrapped in a media screen, right? And so again, you're writing a lot of redundant code. And that's kind of the theme that I have in my heart with vanilla HTML, CSS, JavaScript, is you're writing a lot of redundant stuff, right? The other thing is, when you're like this, when you're editing the HTML, and if maybe you're working on a group, and your group mate made CSS, when you're looking at HTML and you're not bothering with the CSS part because they did it, you have no idea what the hell this looks like. You have no idea what education is or item details. You have no idea what classes are applied to it. And what do you have to do every time you want to find out? Switch tab, switch tab, switch tab, switch tab, switch tab, switch tab. It's annoying. It's boring, right? It's terrible. And so that's my gripes with that. So now we're going to talk about Tailwind CSS, right? Completely not biased. I feel like I'm pushing these technologies really hard, but there are other things that are similar to this if you want to look this up. Anyways, this is what's called an inline styling solution. So what's the difference between a normal styling solution and an inline styling solution? Well, the philosophy is here, right? To solve the first problem that I described, imagine instead of having education, we had a class for every single potential style we could have, right? So there would be a dot flex, and the only line would be is flex. And then it would be like dot width 60, and the only thing in it would be width 60. So then all we need to do is write a ton, wait, hold on, where is it? I need to find it. You just write a ton of classes, right? So if you look here, this is an inline styling solution. So this is flex, and the only thing in that style is flex. This is flex column, and the only thing in that style is just the flex column, right? And that sounds a little weird because you're writing a lot, right? There's a lot of writing you're doing, but the really cool thing is two things. One, you get to understand what is happening to this piece of code without having to toggle back and forth or opening localhost. You have an idea of how it's sort of interacting with everything else. But the other thing that's really, really important is when you edit like one of these classes, let's say you edited, I don't know, let's say this one had flex on it and you got rid of flex. But what if one of the other 4 classes already on it still have flex? Then you're like, okay, which one is it? Then you edit flex off of all of them. But then the item details class on a completely separate page now looks terrible and stupid because you took flex off of that and it looks really stupid over there. So the whole point is we're isolating our styles for 2 reasons. 1, we get to understand why things are working in the context of where we're looking. But 2, we can completely rip and test and experiment and change things without messing up everything else on the site, right? Because you'll have times where you'll make like one quick CSS fix, but you won't look at every single page and every single div of your site, and it looks stupid when you get there and you're like, oh man, when did I do that? You have no idea. So again, that's why inline style solutions are really, really cool. The other thing is I personally really, really loved learning CSS with them. So imagine you're experimenting with something, and as with all things, right, we're in class, we learn a new programming language, we just, write out like a few print statements and like print variables, and we're kind of just sandboxing, right? That sandboxing stage is when you learn a lot of things. Now imagine how counterintuitive it is for you to go back and forth, back and forth, back and forth to see those changes happen. Tailwind being inline and live refresh is you could have your window up on the right, you can have your editor on the left, and you delete one quick thing and automatically you see how the styles move everything, how they change. And so it helps you a lot understand not Tailwind CSS, but just CSS as a whole, right? understanding what flex is, what grid is, what layouts are, right? It really, really helps because it's really, really fast. Another thing that's really, really cool, and you can override this if you don't want, but Tailwind actually has an opinionated design system. What do I mean by that? I think I'm going to show you next slide. Hopefully I do, or I'm going to look dumb. And it's also bundled and compiled for optimization. Every time you send over your CSS file, every character you send is more information you need to send over the internet, and that's more latency, right? And of course, like on the scale of a personal portfolio, it's probably not going to matter, but when we're talking at scale, a big CSS file can slow down your site, right? Tailwind CSS automatically, like if you were to open it on like production, like the first style is named like A, the next one's like B. It's like, okay, what does this mean? You have no idea, right? So it kind of like helps you with that. Okay, awesome. So I do go over it. Oh, they changed their homepage. Okay, here's what I mean by stylized opinionized design system. All of these widths, when you write normal CSS, you have to think, do I want pixels? Do I want view width? Do I want rems? Then you have to learn what the hell all of those different things are. Or do I want percentages? Do I want fractions, right? Tailwind just says, okay, this is padding 5. You go, what the hell is 5? You don't need to know, right? That's the whole point, is it lets you take yourself away from all of that unit system, right? And so not only are they opinionated on like the spacing to make everything look like it just belongs where it belongs, but they also have a whole color system, as you can see here. All of these, I don't know why it's not letting me scroll within it, but as you can see here, you could say, for example, instead of having to get an exact hex code, you could say yellow 950, and that's this like weird doo-doo brown. But if you wanted to say like yellow 400, that's what would show, right? And so this design system, as you can see here, all of these colors are picked with intention to work with each other. Now, if you want like a I don't know, a card, and you want to have it sky, and you need like some more variation, just use a different hue of the sky color. And it's meant to go together, right? It helps take away a lot of the design thinking if you're not as design oriented, because I know I'm sure as hell not, but on solo projects you gotta be, right? You gotta put on your big boy pants, you gotta do what you gotta do. They also help you with all of these animations, right? The grid layouts, like come on, this looks beautiful, guys. And so again, this is all opinionated. It helps you not have the fatigue of making the decision. And as you can see here, this is what it looks like when you apply all of the classes. So it still does have a CSS file, because at the end of the day, your Google Chrome doesn't understand Tailwind CSS. It's not like that's something that's built into Google Chrome. So at the end of the day, Tailwind is going to have to make you that CSS file, and you can kind of see it happen live. This is a pretty cool demo. They didn't have this last time. But yeah, cool. So Tailwind CSS is something that I really advocate people to just start learning. If not Tailwind CSS, there are other inline styling solutions that I think are super, super great. And so let me do a little bit of code snippet demoing of why I think Tailwind's really cool. If you're writing in VS Code and you get a Tailwind IntelliSense extension, it's a mouthful, you just search up Tailwind and it'll pop up. Every time you hover, so this is, you don't see it, but my mouse is hovering over this. I actually get the full breakdown of what that is, right? So I hover it, and it tells me exactly what normal class Tailwind's gonna map it to. Same thing up here. Now, here's something I'm gonna get into that's a little more complex. Another thing that Tailwind helps you handle is this mess. Remember how I talked about responsiveness? Well, Tailwind has something called a utility class. And in front of any style, you can put SM colon, MD colon, LG colon, or XL colon. And what that's saying is only apply these styles if the device is small and above, medium and above, large and above, or XL and above. And those are mobile phones, tablets, laptops, and desktops, in that order, from a conventional standpoint for your web design, right? And so this, I mean, come on. I like that a lot more than the other thing, right? It really, really helps you kind of have, and again, the other thing about this CSS thing is when your CSS gets long enough, your code, you could imagine, not only are you tabbing between HTML and CSS, but you have all your desktop code up here, and all your mobile code down here, and then all your iPad code down here. And not only do you have to tab, but you have to scroll between each of those 3 sections to understand how this code is going to change through different viewports. But again, it's all inline. You have a good, firm understanding of that while you're writing it, while you're working with it, right? The other thing is down here too. Let's say you say, screw it. I don't want to use Tailwind's design system. I don't know what 5XL is. I want this text to be exactly 237 pixels for whatever reason. You can open square brackets and pass in units as a function to Tailwind. So they say, okay, you don't want to listen to us? Fine, we'll give you that option. 85 view width is a unit in CSS where I said I needed to be exactly 85 view width. I opened up the square brackets, and now it automatically generates that class for me. So I can completely go off the rails and ignore it. Same thing with your color scheme. Let's say you really don't want the Tailwind color schemes. Fine. You say background dash open bracket, and you pass in the hex code. You pass in the HSL. You pass in whatever you want, right? And so it's opinionated, but it's not enforced, right? And there are a lot of frameworks that do enforce. So that's another reason why that I really do like Tailwind. Just a general idea or kind of a pointer for learning CSS as a whole. It can be rough at first trying to grasp and understand things, but the biggest things that you can kind of like start looking at is the box model and understanding layouts. So there are a bunch of CSS cheat sheets out there. This is the box model that I'm talking about, and you can very clearly see the, let's say here, I want to go here. Give me something cool. Give me this. So this is, you can actually see the box model live when you look here. Let me see if I could find the dev tool for styles. It might look like a bot here. I haven't done this in a minute. Computed. There you go. So look, remember this thing I was talking about, the box model? Same thing, right? It's built into your dev tools to help you understand and try to figure these things out. What this is essentially the blue is the actual content, right? What padding is it is space within the element. So for example, imagine I had words here and the background of this was white. Doing this gives me more room within the element. And then the border is pretty self-explanatory. It's something that goes around the element. And then your margin is the distance from that element to another element. So I wish I could find a good example. Should be able to do this. No, I don't have that style built in. Anyways, so the blue is the actual content. I had padding at the top, but at the end of the day, I could have used margin. This is also a bad example. Oh, this would be a really good one. Let me go find the button. Too low. There you go. So here, the actual content is the text. As you can see here, projects is the blue, because this is the center of my box model. This is the actual content. But if you look at this huge monstrosity of a class, you can see right here that I have padding x4 and padding y2. That's what those two Tailwind styles correspond to. And so what that is it's this. It's the green. If I hover over it, you see the green around the text? They kind of look like the same color, right? So that's what padding is. And again, that's space within the element. Notice how it's the same color. But if I go up here, let me see. See that orange? That is margin. So that is the distance from the element to another element, not within itself, right? And so where do I have that? I have, let me see if I can find the margin. Oh, here it is. It's manually added by this flex layout because I'm giving it a space of 4, right? So I have a margin of 4. All of that's pretty crazy. And again, these are things that you have to take time to learn, but the best part is you can just rip out classes and move them around and you're great, right? And let me see if I could actually, no, I'm gonna move on. The other thing after you learn the box model, the really good thing to learn about is layouts. So there's two that you're really going to be using a lot. Then there's a third one that's a little more niche, I would say. It's flex, grid, and absolute are some of like the really, and relative. Those are like the 4 big ones that you're going to run into. This is a cheat sheet for flex boxes. So flex container, flex items, flex grow. Again, all of these things that you kind of want to experiment with by Googling class names. W3 School is an excellent resource. And crazy enough, GPT is really trained on Tailwind. It's gotten really popular, so if you need help debugging Tailwind, it knows that too. It's not too modern, right? So it's a good way to learn. So we've talked about how's a website shaped, how does it look the way it looks, but now we want to know how the hell do we use it, right? How do I, when I click something, have something cool happen, or when I hover my mouse, things appear, right? That is called React, or not React, sorry, JavaScript. I went ahead of myself. So traditionally, JavaScript is what runs in your browser, right? And it still is what runs in your browser. At the end of the day, when you write React, Google Chrome doesn't know what the hell React is, in just plain honesty. React is a layer that you develop with that then makes JavaScript, right? At the end of the day, all that hits your browser is HTML, CSS, and JavaScript. They don't know what JSX is, they don't know what Tailwind is, they don't know what React is, right? So again, these are the bare tools that make it. And you can write just JavaScript. You can write it raw, you can do whatever you want, and again, it gets a little out of hand, right? So another thing that I want to point out with JavaScript and React as well is it's something called event-driven programming, which is something that takes a little bit to shift your brain to if you've only done class projects, right? Because in class, we're taught things like Python, taught things like C, like Java, right? And with those, that's sequential programming. When you go to the top of the main function, it goes to the bottom, and it's done. Maybe we'll get a little weird and we'll throw a function, but at the end of the day, when it hits the function, it goes to the function, goes to the bottom, keeps going, calls another function, goes to the bottom, keeps going, right? It's from top to bottom. It's in order. And again, you might have a loop here and there, but the whole point is that you can expect and trace exactly how it's going to run with enough time and effort and insanity, but it is sequential. JavaScript is something called event-driven programming, and by that, it makes a lot of sense, right? It does things when things happen, when an event happens. And an example of that is when I hover something, right? How would your C program that happens sequentially know when I hover my mouse to make it light up, right? It's called an event listener that you'd have to like work with event-driven programming, right? Or you could just set like a timer and really, really, really hope that they hover at that exact second, it goes off and then everything works, right? But that's event-driven programming. So this is an example of what I had in my first site. This is a more complicated JavaScript example, but essentially what this is doing is it's creating something called an intersection observer, which it takes what you're looking at in the screen. So you know how a website may be this big, but you can only look at this much at a time. And it watches you scroll. The intersection observer tells you what's in that view, right? And then basically, I had this cool little animation that when you scrolled in, something slid, right? You've seen that all the time. You scroll and then the text like, whoosh, it's all fancy and cool. Well, to do that with vanilla JavaScript, you set up your intersection observer. When you scroll, it adds a class, right? But really what JavaScript does is, I'm gonna scroll back so far. It lets you, either by class or by ID, hook into an element and change it when things happen. That's basically all JavaScript is, right? So what you could do is you could say, okay, I'm gonna make an event listener, and that's a really big thing in JavaScript, on this div. And whenever someone scrolls over it, I'm gonna change this class and make it visible. So you can modify with JavaScript a lot of things. The text that's in the HTML, right? You could change, imagine when you, log in and the user at the top says your name now. Congrats, JavaScript changed the HTML to say your name. You can also change the styles. And so JavaScript is kind of like the brain of your website. It modifies the DOM. It tells it what to do. And by the way, this is called the DOM. It's the document object model, right? I'm going to use that in like 10 minutes. So keep that in your mind when I say DOM, because I'm going to bring it up a lot. But that's what JavaScript is, right? Another example is, here's what I did. So this is also a little more complicated, but when I had a nav bar, you know what a nav bar is, it says like about, home, projects, etc. What I wanted to do is when you scrolled through each section, I wanted the section you were on to light up on the nav bar. Pretty cool effect, it wouldn't be too, okay, it's this, right? So basically what this is, again, document. The D in DOM, document object model, we can grab that element and now we're holding on to a reference to it. It's almost like a pointer in C. We're holding on to that piece of the website. And then once we have this, we were able to go ahead and modify things, right? So basically what this is saying is window.onScroll, right? So when I scroll through the window, if the position overlaps with some of these things with the section that it's in, it's just gonna set color active right here. The rest of this is just code to make sure that it's in the right position. But you get how JavaScript is code that listens to what you do and it interacts accordingly, right? But again, this can get crazy out of hand with really complex state management systems that you want to make. Another thing that I want to bring up, TypeScript, right? I think this is a really, really important part of development and part of learning web development. TypeScript is basically JavaScript with types. That's literally it. A lot of people are like, oh, I might know JavaScript, and maybe we're working on, you make it to Poos and you're working on the large project now, and you're like, we did JavaScript the first time. I don't want to learn TypeScript. At the end of the day, the learning curve for TypeScript from JavaScript, it's almost identical until you get into like really, really weird stuff, which then it gets kind of out of hand. But an example, and I want to advocate for TypeScript because I'm a huge fan of type safety. I think it makes development a whole new world, right? And so type entity item. And this is it. So I defined a type for a project I was making. And basically, it can have a label, which is a string. So like, what's the name of the entity we're working with? And then it can be a character, a city, a faction, a quest, or a building. And guess what these are? These are also their own types. So you can kind of like create your own system. And now you're probably asking, why the hell do I care? Well, that's because in JavaScript, you could add the string hello to an empty object of zeros and get false. That's just how things are. Like, it's weird. You have no rhyme or reason about how JavaScript works. You can add an empty object to an empty array and get true, but an empty array to an empty object in that order and get false. It makes no sense whatsoever. JavaScript has no idea about its types, and so to save yourself from that trouble, that headache, and that error, because imagine you're writing code and you expect your website to give you text, and it gives you like, I don't know, like hexadecimal like numbers. And you're like, okay, well, where did we go wrong, right? TypeScript helps you catch those errors in build time so that you never deploy anything that's gonna give you that weird error, right? Types are important. JavaScript's dynamically a type. There you go. Imagine trying to divide an array by a string and getting like true or false out of it. It doesn't make sense. The other thing is linting and autocomplete, which I'm about to give an example of right now. This is the beauty of TypeScript, right? Again, let's go top to bottom here. So I defined menu item, and this is a project I did for the web UX class. Essentially, I had to build a site for a restaurant. We had to build a site for a restaurant, and it was a mess. But each menu item we were able to put into this, right? ID, name, description, price, category. And the really, really beautiful part of TypeScript is I had filtered items, which again, this is React syntax, which I'll get into soon, but the whole point is that this is an array of menu items. We can recognize this syntax at least, right? It's an array of menu items. And when I do filtered items dot, my code editor already says, look, length, map, pop, push, reduce. What are these? These are operations you can only do to an array, right? Imagine trying to iterate over the integer 1. That's just not something we can do, right? But it knows. Now when I index at 0, and I put dot, what is it listing to me? It's listing ID, name, description, price, and category. And this TypeScript allows you to have a much better understanding of what you're working with, what you can expect coming in, and this gets really, really powerful when you start working with external third-party services like APIs and whatnot. Imagine trying to get like maybe a Discord API, and I had to do this because the Discord API is terrible, right? You're working with the Discord API, and you have no idea what members you have taking in. Am I getting their user ID? Am I getting the guild ID? Am I getting an object of IDs, right? So all you need to do, if they have types defined, which thankfully they do, all you need to do is drop a dot and just kind of see what you're working with, right? Am I working with an array? Am I working with an object? Am I working with what members are in the object, right? And so TypeScript, by defining all of these things, lets you have that understanding. And again, all of the stuff that I'm kind of advocating for, Tailwind, TypeScript, all that, is getting you integrated with your development environment and understanding what you're working on. Because you should be focusing more on writing the code and making decisions and figuring out what the code actually does, period, right? That's just the development philosophy. And so that's TypeScript. That's it. A good 3 slides on it. Nothing super crazy, right? Now, this is React. React is probably one of like the meatier parts of learning web development because it is such a big component of front-end development, and I think this is going to take a lot more time on your own time, but I'm going to introduce not how to write React, but the place that React serves in your website and why did it come to exist and how, like generally what is the purpose of it, right? So it is a JavaScript component framework, not UI framework. Scratch that, delete it, burn it down. It's a component-based architecture. I'm going to talk about what a component-based architecture is and why components are really, really powerful in web development. It's also client-side only with like an asterisk on the side. If anyone knows Next.js, don't quote me on that. State management system. Again, this helps you kind of have a better control of how your website's looking and how to respond accordingly. It makes your website reactive, which astonishes you how they got the name React, right? Optimize interactions on the DOM, that big document object model, and hook-based bindings, which I get into in a little bit. So the biggest thing about component-based architecture is it allows you, imagine, okay, again, we're going really far back. This right here, right? You can consider this a component, correct? This is a piece of code that we're reusing over and over and over again. Pretty straightforward. And sure, we accomplish that again with this, right? But there are still some things missing to really call it a component. Imagine, that's a good example. So imagine all of my skills, right? Instead of hovering over them to display their name, I want to click them. So I want to click each of them to show it and leave it there. It's a toggle. I don't want it to go away when I hover my mouse. So I click on the first skill, and I set that it's being hovered where, right? I would have to make an array of this size, keeping track of a bunch of true or false values for each of those, right? Does everyone follow that sort of line of reasoning? Because I would need to keep in mind the specific state. It's a really, really important word, the state of each of the elements. And so I would have to take more memory, and I have to make that whole array and then make sure I manage it properly, right? So what components do is they take this idea of the whole dot map, and then they take it to the next level. They kick it up a notch, right? So imagine each of these mapped pieces has their own variables, their own functions, their own API calls if you want, their own everything. A component is basically a piece of your UI, of your HTML, that's a function, and you can pass in whatever you want. Imagine you wanted, let's say you wanted a card, right? Like a little card on a website that pulled from the LinkedIn API to show a headshot, what school they went to, etc. You could make a component that as input grabs their LinkedIn ID, and when you render each of them, they each pull with that function their own LinkedIn information, each one at a time, right? So again, we can have our own variables, our own functions, our own state in each of the components. That's the really cool thing about a component framework. And so that's what a component-based architecture is, right? It's a little more than the whole dot map. And in all honesty, you can dot map data each into their own component, and you should. But the whole point is that we're giving them their own state, right? Imagine a function, but it's for UI, and that's exactly what a component is. What is state? I bring this up a lot. It is the current condition of the application. Sounds a little vague, but by that I mean the interactive condition. So where the mouse is. Remember how I said I want to toggle everything? When I click it, it stays up. When I refresh the page, I lose all of that information because it's stateful. It is in the context of our current session. It is state, right? And so some examples of that, if a drop-down is open or closed, that's a perfect example of state. When you click something and it does the little thing down there, that's an example of state. Whether a modal is open or not, that's the little dialogue that pops up when you're like, are you sure, right? Those things are really good examples of states. And it's a visual representation of consequences, of things that you've done on the website that make something. That's the best way to describe state. If you can't see it without you doing something to it, it's not stateful, right? It's just how it is. So this is an example of a component. And it's not a very good component because I was practicing React. This is my first time using React. So I actually didn't even take any inputs. I just wanted to write everything as components to get an idea of the syntax. But essentially, you make a function, and that function returns JSX. This is a very, very simple component, again, because why? I'm not using any state. I'm not making any functions. So again, this is kind of just me doing it for practice, but I think I have a better one. Good, I have a better one up soon. So here we go, right? This is it. But I want to, here we go. And again, this is still not the best example. I can go dig one up if I really need to, but this is a function, this is a component now, but it actually has inputs, right? So I define a type, an interface called freelance props. And basically, this is when I was doing freelance work. I wanted to show off all the pieces that I did, right? All the websites I helped make. And so you take in the name, the short description, the image, and the link. You pass these in like this, and you return this JSX. And then in this component, I could then, in another piece of my app, I could do .map, and I could just pass each of the objects into this component and render it. Yeah, I don't have an example here, but imagine, again, we want to go back to the toggle example, right? Imagine I wanted to have it toggle so that when I click the freelance, I don't know, it would highlight blue, right? Instead of having to make an array of state outside of here, I could then make like a single value in the component that's like, is toggled, and then make a button here that sets this one as true or false, right? And so each copy of the component that we create is each gonna have their own member with their own true or false value. And that's how we can make the .map thing a lot more powerful, by giving them each their own set of instructions, their own variables, anything that they need to succeed, right? That's all what all the component architecture is. The biggest thing is use state in React, and the reason they do this is for optimizations, right? So imagine if I could just create a variable called isToggled, period. That means React would be listening for every single variable to update. Because again, what's the point of React? We want to update our screen when we do things. We want to react, right? It's the whole point of the framework. So if they listen to every single variable, there would be a lot of things going on. So what you need to do in order to tell React, you need to create what's called stateful data. Again, I use that word a lot. So you use with a hook called useState. Stateful data is different from normal data. Changes in only stateful data will cause a re-rendering of the appropriate JSX. Keyword on appropriate, and I'm going to show you a diagram and an example in a sec. So, do you remember that whole thing I kept talking about with DOM and parent and children and tree? One of the really, really cool things about React is when you modify a piece of your website, it's not going to refresh the entire website, right? It's going to, update and build and redo all of that specifically for the part of the DOM that you interact with. So imagine you modify a component. Instead of having to re-render everything, it only re-renders the things in that component. And it does that by using useState. If you don't, it can't do those optimizations, so they make you use it, right? So basically, if you see here, all of this is in a virtual DOM. What React uses, it uses like a it's a virtual copy of the way your website looks before you do your thing. It does all of your modifications to it and then just smacks it right in, right? And it does state change, compute diff, re-render. That's a bunch of technical stuff you don't need to worry about, but the whole point is you have to use useState for it to work, right? And so this is an example of stateful data. Very, very, very straightforward, but this is how you use the hook from React. So you set the actual name of the variable you want to use. So for example, name. And then you need something called a setter. If anyone's taken OOP, you have an idea of what a setter is, right? But in the sense of React, this setter is important because, again, it tells React, hey, trigger that re-render. Do this whole fancy thing, right? So whenever we use this, it's going to then re-render the stuff that's important, right? And so on change, in the input thing here, we just basically say, okay, I'm going to set name to whatever I'm typing in. And this is the most simple example of useState that I can show you. Another one, the classic React like hello world, is the clicker. So this is an example of a button, and when you click it, it goes up by 1. And you click it again, and it says 2. Click it again, and it says 3, right? Very simple example of state, because again, you have to interact with the website for it to work. But what we're doing is we're saying, hey, here's a component. This is the actual JSX. When you click this button, on click, you call a function called setCount, and you set it to count plus 1. And now, the count that's being displayed here, and these curly braces are how you print a variable into JSX, right? As you can see here, count. And now the beautiful thing, again, about this component architecture, imagine we wanted 10 of these. So we called it 10 times, and then I clicked the first one 5 times, and that one's 5. And then I clicked the last one 6 times, and that one's 6. And each of them have their own state, and they each have their own copy of that count, and they each have, like, it's a component-based architecture, again, right? The other one is useEffect. This lets you do something in response to something changing. It lets you react. A lot of shitty puns here, guys. It provides UI interactions to non-stateful data, and it allows React to react. The way that it works, essentially, this is crazy. This is a crazy, one of my projects again. But essentially, we get some data from an API, right? And again, if it's not stateful data, React's not going to do anything. It's not going to change anything. It doesn't care, right? And so what we do to make sure that it does is we set something called a useEffect. And down here is called the dependency array. And you put into the dependency array what you want it to respond to, right? So for example, whenever I get my new city, whenever it changes, right, I want to react by setting all of the properties that I have to that city, right? So we put city in the dependency array. That's what we want to respond to, right? And now here's the interesting thing. So here's another example. Whenever the cart changes, right, this is again for the restaurant, we wanted to store it in local storage so I didn't have to manage a database, right? And so whenever your cart changes, the one that's in state, we just update your local storage, right? So again, this is us reacting to something. This is us doing something in response to something else. It's an effect, right? Hence the whole use effect thing. Another really cool thing is you can have something called, it's like a constructor use effect. It's called onLoad. So what if your dependency array is nothing? That means this is code that's going to run when the window loads or when the component loads and never again. So this is almost like a good place to have all of your initializations happen. The example for that is the restaurant, again, same code base, is also for a multilingual audience, right? we specifically needed to tailor for English and Spanish users. And so what we do is we greedily assume that most people are starting with English. We set it to English up here, but then right when the thing loads, we're going to do this. And the reason I say that that's important is when you send over certain code, you might not have access to the client when you're running it. And that's an idea we're going to go over soon. But imagine I wanted to automatically give them English or Spanish, right? The issue is that when our server sends over that information, we have no idea of knowing, because where is that information stored? On their phone. Their phone knows whether they're English or Spanish, but when they make the request, we don't know. So that's why this is important. We only run this code once it actually gets instantiated, once the React loads. That's the only time we're gonna have access to the language, the navigator, right? And so those are paradigms you're gonna need to understand between client and server, and that's where React helps. And so here's another example of on mount. Every time the component loaded, I cleared all of the data inside of it just so that it was a clean slate, right? Okay, we've gotten through part one. Hopefully, y'all are still following. Any questions before I move on to part two? Anything at all. And I encourage questions for all of my workshops because that's the whole reason you show up here. If not, you could just watch us on YouTube, right? All good? Okay. So now I'm going to go into concepts, and I sort of started that conversation by bringing up client and server and the use effect on mount stuff, right? This is an important distinction that you're going to need to understand if you're building like interactive applications, is the difference between client and server. Now, for all the people in here that are experienced in web development, I'm going to be going over like very simplified, very dumbed down version just for the sake of learning how these tools interact with it. So don't fact check me, okay? These are big simplifications, but so the server and the client are essentially two different environments that are important for making a website, right? Now, when you're developing something in localhost, it's really hard to understand the difference because both the server and the client are on your same machine. So when you're running a localhost website, the server is actually your VS Code terminal or whatever terminal you're using. And the client is another interesting thing. A lot of people say the client is the machine the site's being hosted on, but in the sense of a website, the client is actually Google or Safari. Your laptop doesn't know how to run a website. Your laptop knows how to run Google, which then runs the website. So the client for a website is always going to be a web browser. Safari, Google, Firefox, Opera GX, whatever you want, right? That's going to be what the client is going to be. And so some differences between the two. Servers, this is as far as I'm going to get into APIs, this is where the API servers are hosted. It communicates with your databases, and why, fundamentally speaking, we don't want to have direct access to all of our vital information on our client, because then if we have that, I could open up inspect element and I could break everything. I could spam the +1 rank button on a certain site and then make someone number one at the leaderboard if I wanted to, right? So we don't want to have that kind of paradigm set up. We do want to separate them. Also, server has no user interface. It's purely running from your terminal. So that means there's no state at all. And again, what I mean by that, if I wanted to access the language of the device I'm using, I can't do that on the server. It's impossible, right? Because the server doesn't have a client. And yeah, it has access to client data. So for example, language, local time, local storage, state, etc. And so this is the extremely simple diagram of what a website request looks like. The client, which is you, when you type in blade.nighthacks.org, okay, it sends a request to a server somewhere. In this case, it's our wonderful OVH that doesn't crash all the time. The OVH generates all of the responses for your website. It generates the HTML, it uses React or whatever other tools you use, but at the end of the day, it makes yourself some HTML, CSS, and JavaScript. And then it sends it back to you, and then you start to see it. Your client starts to render it, you start to see all that information. And that latency, if you ever go to a website and you see that just blank white nothingness, that's the time it's taking for it to go here, for it to get your information, for you to send it back, and for you to see it. So that's the very, very simple architecture for a client and server interaction for a web page, right? Now, how does a React app actually work in this context, right? Because again, I mentioned a lot that Google has no idea what the hell a React is. Google has no idea what the hell CSS or Tailwind is, right? So at some point somewhere, React lives, and at another place in your browser, the HTML and JavaScript live. So what happens in that process? And it's a really important understanding. Basically, the server holds on to all of that fancy stuff. The server holds on to your React, to your Tailwind, to your code and all that. And there's lots of cool stuff you can do with caching and have like a static build set up. I'm not going to get into that. Just fundamentally speaking, it has all of the code that you're writing, right? And what happens is that in this step, in this part right here, while we're waiting on the server, it's going to build all of your React, Tailwind, JSX, and all that fancy stuff that we like writing our code in into HTML, CSS, and JavaScript to send over. Because again, Google Chrome has no idea what all of that is, right? And so that step is really, really important. So the server receives the request, and it packages the app and sends it over as CSS, HTML, JavaScript to your client, to your web browser. And then the client receives it. But then there's an important step you need to consider. Once it gets all of that information, it then needs to render in all of the data. It needs to load everything, right? Especially think about if you're making, let's say you are making an API request. Let's say your code wants to know the current temperature in Idaho, and it says it right on the top of the thing. When the information is sent over to your client, once it gets there, it then needs to wait even longer to go to that API, get the weather for Idaho, bring it back, and then build your site. So again, there's a lot of places you can start to see where bottlenecks can happen, where things can go wrong, where things can be long and you have to wait forever, right? And so there's lots of really cool modern paradigms that help you manage those interactions between your client and server. And this is where things get a little more complex, so please ask me questions and slow me down if you need them, right? So we're gonna talk about rendering. Now it sounds a little complicated, but when you're working with React and bigger tools, you need to sort of understand rendering because it can make a complete difference in the performance of your application, right? So client-side rendering is what I just described, right? We're sending over all of the information in this like little box, right? And this little box is everything your Google Chrome, your client needs to run the website. It's like a nice little package, right? Once it's not going to start like unfolding itself and making a website until it gets to your client, right? So on the server, the HTML visible, on the server, the only HTML visible is things that are not React. Yeah, so when your server has all of this, it doesn't really hold on to any HTML because it doesn't have a browser to render all of that stuff in. It's like purely React. And most React apps are all React. So this is kind of the example. Your server has all of your code. When you send the request over, it bundles it up, and then you get your client, and it then sort of starts to build and render your React app in its whole minified form, right? So this is not the worst thing, but I do want to mention something. How do websites appear on Google? And this is an important thing if you want to, again, the goal of this is to build a portfolio. And if I look up your name, you probably want your portfolio to come up, right? So the idea of how do things actually appear on Google, and that's something we need to think about when we're talking about rendering. It's called search engine optimization. It's the study of how things appear on the internet. And the way Google has all of your indexing for your sites is it does web scraping. It basically goes through all of the things listed there, and the bots basically pull your data and display it, right? But here's the issue. Here's where things get a little complicated. Remember how I said this requires a client to render everything, to understand what's going on, to instantiate all of your JavaScript. The issue is web scraping, like a lot of the bots, they don't have access to a lot of the things that clients have, right? They are not a client. And so a lot of information that's stuck in here and not accessed here really get bottlenecked with search engine optimization. Things get difficult because, again, you have no idea the bots have no idea what's on your server. And so no server data, no search results. And so the example that I really want to show for this, if I type in night hacks, I believe it's 6. Yeah, so we see all of this text appearing here, right? Night Hacks 2023 is a 36-hour hackathon hosted by the University of Central Florida. That's the text that's appearing, right? Where is it? Where is it on the page? It's not there. This is purely metadata. When Google goes and scrolls things, this is the only thing we've given them to index us by. The name of the site, the URL, the page here, and this. awesome, right? There's a lot of things that Google's not seeing about our site that could help. They could help us get better context for our search results, right? Now, the other example that I have is this text right here. We can copy and paste this, minus the triple quotes. It's taken straight from the page, right? So how does Google, how do the scrapers, how does the search results have the understanding of your site? That's from partial server-side rendering, and this is where things get a little more complicated. And the only reason I'm introducing this is if you want to build your portfolio with a certain stack, this is something you kind of just have to be aware of. And so this is, again, the diagram gets a little more complex, right? What happens here is, remember how I described we send information over and we want to know the weather of Idaho? Server is going to have no idea about that information, right? Because again, it's not going to like it changes every time. So what you can do is, or no, that's a bad example. When the user requests a site, what you could do is instead of sending over like this piece of code that once it gets to your client asks for the weather at Idaho, what you could do is you could in your server ask it, put that information in, and then render some of the HTML that's relevant. So basically, instead of bundling it over, like all of it, into this like neat little bow, we greedily put everything that we can that doesn't depend on your client, that doesn't depend on React, that doesn't depend on your Google Chrome instance. We kind of make it ahead of time, right? And so now all of this is on our server, and this is what Google's seeing. And then all that gets sent over to the client is the stuff that needs to be React, the client stuff, the stateful stuff, right? And so again, this is a really, really high like complexity kind of idea that is like maybe what, 4 years old, and that's considered pretty new for technology and whatnot. But the idea of server-side rendering, put simply, is definitely super good when you're trying to maximize your appearances on Google. And so that's the gist of it. Any questions about this?
So like that would be like what you were describing. That would be like, for example, why like certain elements of like lazy loaded.
Yeah. So instead of like lazy loading them when it gets there, which is like waiting for them to be instantiated, you could also on the server, if it's like imagine you don't care that the weather of Idaho might change while you're in your session. Let's say we're imagining people can only be on the site for 15 minutes. Like who's going to sit and look at the weather of Idaho for 3 hours, right? If you think it's never going to change, you could actually pull it on the server before you send it over. And instead of lazy loading and waiting, we're like, okay, it's probably not going to change. Why send more code over to keep updating it? We're just going to do it once on the server. We send it over, prefetch it, right? And so it helps with a lot of those kind of interactions of waiting and loading and all that stuff, right?
And how would you do that?
So there's a lot of ways to accomplish the whole server-side rendering gig. Any other questions before I move on? Because that was good comedic timing. No, we're good. Okay. So to handle all of this type of stuff, things get a little more high complexity technologically speaking, right? Because now we're writing code not only for our client, for our web browser, but we're starting to write code that actually impacts like more of the server, right? And so the best way to do that, not the best way, but my preferred way, is something called Next.js. Now, what this is, there's a lot of things that Next.js can help you with, but for the scope and content of this workshop, I'm only talking about the prefetching and server rendering and all that type of stuff, right? What this allows you to do is these very same React components that you've been working with. Remember how I said that they're purely for the client, right? They're only supposed to be on the client. It lets you write things called React server components. And what are these? Well, they're basically the exact same thing as the other components, except there's certain things you can't use. Can anyone take a guess of certain things you can't use if you're rendering it on the server? Any guess? No one's gonna be bold enough?
Any client input?
Any client inputs. That includes local storage, local time, navigator language. What about another thing that's really, really powerful on the client? Your state. So remember, use state, use effect, all of those wonderful little gadgets. Well, we just can't use them in the server components. Why are we limiting ourselves? Why do we want to do that? Well, because if you don't have anything in there and you tell Next.js, you say, hey, this is on the server, it's going to go, all right, and it's going to put this in this box. And it's going to put more and more into this box. And really, when you're making things, you want to lean in as heavy into server as possible because it's quicker in most cases. You see the load time a lot more instantaneously. And the other thing, it helps with your search engine optimizations, right? And so, yeah, that's what Next.js is. It's a server framework. It's a meta framework. It helps you write the code on your server. And so, basically, it handles routing for you as well. That's another thing you probably haven't really considered with React. When I go to my website.com and I go to website.com/hello, how does our website know the difference, right? That's called routing. And so that's something, again, that happens on your server because what handles those URL requests? This guy. So you type your URL into the server, and the server needs to figure out what resource am I going to serve them based on that URL. And so that is called routing. And so to do routing with React, you're going to need some sort of framework like React Router or whatnot. Next.js just kind of does it for you in a really simple way. It's a lot like normal HTML. So if you have your main page, you make a folder called hello, and you put content in it, and when you go to URL/hello, it just goes to the hello folder. Super nice, super clean, super quick, right? It also lets you have metadata optimizations. I'll get into that, as well as middleware and images and links. Again, these are a little more high complexity things. These are the two big things that we're going to kind of be talking about. And so I'm very happy to say that my portfolio is over LinkedIn. That's kind of the flex, but this is metadata. Remember how the text that I searched up wasn't this? You're allowed to, with these frameworks, define something called metadata, which is almost like a little Imagine this box right here, the React part, not the HTML. Imagine you put a sticker on it. Imagine you said, okay, this site has tags like software, hackathon, all of that. That's what the metadata is. And this is when I was using metadata for my site. But as I showed you already, my site is now fully rendered in SEO, and you can see all of the text there. So yeah, all you need to do to define a client or a server component in Next.js, look at this. That's it. So if you want it to be on the client, what do you tell it? Use client. If you want it to be on the server, guess what I would write? Use server. It's not super that's all you need to do. That is the only distinction you need. And the beautiful part is that when you write use client or use server and you have an extension for this, if you even start, if I didn't have use client, because Next.js, remember how I said server is usually always better? If you have none of them, if you have nothing, it's going to assume server because it wants you to use server as much as you can. If I even began typing import React and I didn't say use client, my whole screen is red. It is like I just put in the last digit for the nuclear launch codes. It's going, this is a client, this is a server component. Get the client out of here. And then you just put use client and it shuts up, right? So it helps you, it guides you to figure out what should be client and what should be server, right? This is the routing, this is the file structure. As you can see here, so if I went to my app, it goes, so the way that it works is page.tsx is the actual, the information you're gonna see when you enter that URL. So in main, there is no slash here, it just goes straight here. So if I go into my website, dvl.dev, this is the page I would see. But if I wanted to go to /projects, let me see if I have another, there you go. It would just grab the page.tsx from experience, projects, or skills. Boom, routing, congratulations. You know how to use folders, I hope by now. So that's it, it's just folders, right? Next handles all that cool stuff for us. Another thing is too, this is for more when you're working with full stack applications and really, really deep interactions. These right here are URL params. And by this, imagine on Instagram, I went to instagram.com/nighthacks. But then I went to instagram.com/Dylan. Everything after that slash is a parameter because there's no way in hell someone in Instagram made a page.tsx for every single user on Instagram as they uploaded. That doesn't make sense, right? So this is a URL param. It lets us dynamically fetch pages and do things based on the ID that you're passing into the URL, right? And there's plenty of examples of this. All social media sites work this way, right? Again, LinkedIn does the same thing, right? So that's how we can get that information and make our page.tsx dynamically when you request it, right? And so look, this is how easy it is to use this in Next.js. So if you make an interface called page props, and remember, this is world ID, right? It must match case sensitive, but you say world ID is a string. And then this is it. Const world ID equals params. And now I have the ID of the world I'm on. If this was Instagram, I would say const user ID equals params. And then down here, I'd make an API call to get their user information, and then I'd return it down here. Cool. We now have a page that completely responds dynamically to who that you're searching up. Same thing with this. This is just like 2 slashes. So it's like, hello.com/Dylan/posts, or like slash an ID of a post. Now we're going to the specific user getting the specific post. And again, both of these are query params. They're kind of wildcards that you use, right? This is the metadata. This is the crazy thing about Next.js. You just kind of like make an object and it does all this, but essentially what this is, remember, it's the label. It's a little label you slap on the box so that Google can help understand those things. And if you remember this right here, this is what we saw when I was doing metadata over here, right? So I defined that, and that's how we set that text for the Nighthawk 6 site. Is we defined it with the label, but it doesn't know much else after that. And then description, open graph. If I sent you my portfolio over Discord, open graph kind of helps with that embed. If you ever sent like a website over Discord and it's just a link, but you send something else and it's like a huge picture with like a description and like colored background and all that cool stuff, that's all of your embed stuff. And then the other thing you can do is there's 2 files you can make called a robots and a sitemap. These are things that, remember how I said Google is searched by all of those robots? This is basically holding the robot's hands and going, yeah, let's go this way. This is where you should look. And look, I even have priorities. So you could say like, okay, the home page has a priority of 1, experience and projects have a priority of 0.9. The crawlers might not listen, but again, it's just a hand-holding thing to help them get where you want to go, right? Same with robots. This one's a little more complicated. I'm probably not even going to talk about middleware. And then deployment. This is the last section. I think this is probably like literally 5 slides. So this is how you create an app with all of the tools that I have shown today automatically configured and installed to work with each other. Assuming you have npm installed, right? npx create next app. I think the command might have changed to npx create space next app. I don't know. You just look up Next.js and it'll tell you how to start, right? And what this is going to do is it's going to give you all of this stuff that I showed you here. And it's going to give you like a bunch of sample pages that you can edit, you can start poking around with, and start sandboxing the things that you've learned, right? If you use Next.js, and this is like crazy shilling for Vercel, if you use Next.js, and you can host it anywhere, but Vercel has an extremely easy deployment for a site you make with Next.js. The sole reason is, quite frankly, Vercel owns Next.js. And so they are super integrated with one another, obviously, and so it makes it super easy. To deploy a site on Vercel, you sign in, you click open GitHub repo, you click on the repository, your site's online. Awesome. You want to add a domain, you copy and paste the domain, go to your DNS, add 2 lines, and it's up. Super cool. What's up?
What does it mean by free for most use cases, though?
So I was going to get into that because I have a lot of gripes with Vercel once you pass a certain line, and that line is when you start developing full stack applications. By that I mean once you start using APIs, once you start using databases, once you start hosting the API on there, using a third-party API is fine. If I want to pull an API from Idaho Weather, that's okay. But when you're hosting the API on there and you're doing all that stuff, Vercel gets really nitpicky with what you do. One of my best examples of this is I was building an AI application, and Vercel has a very strict 3-second API runtime, right? And if it goes over that 3 seconds, it fully outwrites all network requests that come in and out of that API. Now it's an AI application. I think you all have seen ChatGPT load for longer than 3 seconds. So immediately, as soon as I put it on Vercel, it kept canceling all of my requests. It was unusable. Couldn't work. The other thing is too, one of my applications, Loot Code, we needed to store and modify file data on a ton of different problems. Vercel, since it's on their own fancy partition, cached, edge, CDN, super servers, right? They don't allow you to write to the file system because that's a security vulnerability, right? You're sharing these servers with other Vercel apps, and so now my entire project's a dud on Vercel because I need to write to the file system, but I can't, right? So there's a lot of limitations once you start getting into bigger things, but when it comes to a site that is mostly static, like a portfolio, it's genuinely free, instant, automatically deploys. Whenever you push a commit, it will rebuild your site, re-upload it. It's extremely simple. That's why I say it's a really good choice for most use, or for some use cases, right? So use Vercel sparingly. If you're gonna start building a full stack application, I'd fully recommend trying to think of another hosting solution. Shameless plug, my Coolify workshop's now live on Nighthacks, and I fully talk about how to host things like that on there to do all of those things, right? So I also go into that a lot more in the part 2 of this workshop if I do end up running it. So don't worry about that, but for a static site, Vercel, super easy. So, nice little bonus section. What now? This is the part where I got a lot of boos from my mentees, but I'm not like holding you guys accountable for this. I asked them to make a portfolio. I told them, I'm not doing the second half of this workshop until you all show me your portfolio. And I held them to it. And it took them 3 months because we were like in the middle of fall semester and we were like busy with stuff, and then winter break came, and it's just whatever. But yeah, they all built their portfolio. And the reason I say that, I did that in this way, is because the next workshop is gonna be a lot more technical, right? A lot more focused on API, on databases and all of those things, really, really intricate things like RPCs and REST and all that type of stuff. And I told them, you're not gonna be able to keep up if you don't at least understand the front end part, the static part, and work with the tools first, right? And so I told them, make a portfolio. Now I'm suggesting you all make a portfolio. I'm not telling you to make a portfolio because I can't do that. But for them, I had leverage. I could hold it over them. So portfolio, you can listen if you want. If you can tell me to buzz off if you want. I don't care. But some really cool things about making a portfolio. I made just a few, like 3 simple challenges just to help you if you do want to make your portfolio, not only make it, but make it a challenge to learn the tools that we talked about today. Those 3 things, pretty straightforward. Make it extensible by JS mapping. That's the thing I talked about with the .map object. Please don't write redundant code. I will be so sad, right? Make a good sitemap, robots, and metadata. How do I do that? Literally look up this word, and this word, followed by Next.js, and there's docs on how to do it for all 3 of them. Add some sort of interactivity with React. Again, that could be like clicking a modal, or like maybe like instead of making your projects have all the information on it, you could have a click more button, and when you click it, it goes and it opens up some cool thing for you to see, right? That's what I mean by interactivity. And yeah, generally doing that will help you learn a lot. And at first, the issue with learning a lot of new tools when it comes to code is at first, you're not even struggling to understand what you're doing. You're struggling to get through the syntactic curve of the programming language. So by taking a portfolio, which, not saying that it's easy, but objectively speaking, it's easier than making a full stack application. You're going to use this as a way to practice the tools syntactically so that when it's time to make an application, a full stack app that you're passionate about, that you want to work with, you're more focused on writing the code than you are figuring out how to write what you want to write, right? That was a lot of rights in that sentence. Another thing I wanted to put here, also shameless plug, I'm not like promoting these guys or whatever, but I get a lot of questions, especially when I introduce like tools that are a little more niche. People come up to me and they're like, how do you know? Like like Coolify, for example, if anyone went to my Coolify workshop, I see maybe 5 or 6 people. How do you even discover these tools? Like, how do you know they exist? Honestly, you need to be up like to date with news, and that's honestly step 0, not even step 1. You can't learn tools if you don't know the tools even exist, right? You cannot start that progress until you understand like, oh, this is cool, let me start learning it. And so these guys I think are pretty good. Theo's going a little crazy right now with like being like low-key like drama alert clickbaiter, but like the other 2 are pretty solid. I learned a lot of the tools that I'm exposed to, not just learning about the tools, but learning how to use them. Fireship has a really, really great course. It's like $25 for 3 months right now, I'm pretty sure, on React, Next.js, all of those things. Again, I'm not shilling. It helped me a lot. I did it before I started my portfolio, and when I got to my portfolio, all of the syntax felt a lot more natural, right? And so on YouTube, or I think Theo's like a Twitter warrior. I'm not on X, but follow them all on YouTube, right? And then what's next? These are just some of the things that I talk about in the second workshop. If you do decide to show up, this is TRPC, databases, ORMs, stuff like that, component libraries, etc. All of these are the second half of what we use on our dev team. It's what I've used for most of my projects. So these are all kind of things that I think are really useful. And then, yeah, I think that's the end. That's it. And is that everything? Yeah, that's everything. No extra slide. So thank you guys.